Now we're ready to do one of these challenging ones. We have degree 3 over degree 1, so this won't be an oblique asymptote, it'll be parabolic. But we're going to start the same way. We're going to start with synthetic division, 0 in the denominator of 2, and then 2x cubed, 0x squared, 0x, and a 4. Bring down the 2. 0 plus 4, 2 times 4, 0 plus 8, and then 16. So our remainder here is 20. And now we can rewrite this function as 2x squared plus 4x plus 8 plus our remainder function, 20 over x minus 2. All right, and we would call this our r of x. This is going to be relative behavior in the middle, and then the end behavior is going to be a result of what this guy does. And now to find some more information here, I'm going to set the numerator equal to 0 to find my zeros, which means 2x cubed has to equal a negative 4, which we can do since it's an odd exponent. Divide by 2. X will equal the cubed root of negative 2 or negative cubed root of 2. That value will make y equal 0. And the value's irrational, but I know it's between negative 1 and negative 2. The vertical asymptote, there's one of them at x equals positive 2. And then the y-intercept, plug in 0, you get 4 over negative 2. So that's negative 2. Now let's take a look back at our quotient function. That will be the asymptote of the end behavior. So that's 2x squared plus 4x plus 8. And it's a parabola. It opens up. That means the end behavior will approach positive infinity on both the left and the right as x approaches negative and positive infinity. Ultimately, when I go to sketch this graph, I'm going to want to make a reasonable guess at where it is. So I'm going to rewrite this in vertex form. I'm going to factor out the 2, leaves me with x squared plus 2x. And then half of 2 is 1, so I'll do plus 1 and minus 2 times 1 plus 8. This turns into a nice perfect square of x plus 1 squared plus 6. So my vertex will be negative 1, 6. All right. Now I can take some more information on the sign chart, and then I'll be ready to graph. I'm going to erase this stuff that's going to get in the way and do my sign chart. My critical places are between negative 1 and negative 2, and over at positive 2 is my vertical asymptote. So between here I have to know signs. Our end behavior, we know that as a parabola that opens up, we're going to end positive on the left, positive on the right. And in the middle, we've got the value when x is 0 is going to be negative 2, so in the middle it's got to be negative. And for information then, our asymptote here occurs at x equals 2. And then this other asymptote, this parabolic asymptote, that's going to be a little bit different. I have a vertex at negative 1, 6, and then I have to draw some kind of a parabola for the end behavior here. Not too worried about the shape's accuracy as long as it opens up. And now I'm ready to plot my points and sketch my graph. I've got a 0 somewhere in here beyond negative 1. And down here I have a y-intercept. Other than that, I have no removable discontinuities, nothing else to really guide me. So I just have to follow my rules here, positive to the left, negative to the right of this 0. And that's going to look something like this. And that's going to look something like this. And then on the right of this asymptote, it's got to be positive, so some kind of a branch here. All right. there we go. Let's take a look at some of the graphs we've looked at. This is your basic one, our old friend. Y equals 2 is the asymptote. Here the asymptote is going to be, it comes from doing synthetic division, it's going to be oblique, and it comes from the equation I get the q of x. And this one, it's going to be a quadratic. We just did it. And the end behavior ended at positive and positive infinity because it was a parabola and opened up. Here I've got x to the 4 over x. That acts like an x cubed, which in the middle has a little difference from the oblique, but really still ends at negative infinity on the left, positive infinity on the right, because the ratio of the leading coefficients was still positive. And then over here, positive again, and 5 minus 1 is 4. This one acts somewhat like a parabola, so we get positive infinity, and you need to know how to find the behavior. Here's from a graph, it's pretty easy, but from the equation you just do synthetic division and get that q of x equation. And now to summarize what we've learned about rationals, when the numerator degree divided by the denominator degree ends up with less than 1, could be a 0 or a negative, or basically the denominator is higher than the numerator, we know that the end behavior approaches 0, y equals 0. And in equal to 1, it's the ratio, it's the ratio of the leading coefficients. And then greater than 1 is what we covered today. We went in and defined this a little better, whether it was positive or negative infinity by this function q of x that we get. And here's a table you can take a look at. You don't have to spend a lot of time on it, but it gives you the information in a summary form. Here's your on your own. Good luck with that, and we'll talk in class.